Today the discussion points are already reflected in your screen: the infiltration, runoff, evapotranspir, interception by stem through fall. So let's see how much part we are able to cover here, isn't it? And then we try to understand the concept behind this also. And these are just some small topic that has been given in your syllabus. So we need to discuss here in detail, right? So basically today I like to cover this topic. Among the main topic we have interception, stem flow, canopy drip, and throughfall. So first we need to understand this: what is interception, what is stem flow, what is canopy drip, and what is throughfall. So through the image I like to explain what is interception, right? So you just look at the image first. You can easily understand that what is interception basically. So before going to the technical aspect, you people have witnessed, you have seen the trees, isn't it? Every or different kind of trees you have seen that, even the height, their size, everything you have seen that, isn't it? And when there is a rainfall, any kind of precipitation is going on, right? In any form, whether it is a snowfall, whether it is a rainfall, hailstorm, anything, right? So if vegetation will be there, so vegetation is going to modify, right? Try to listen to it. Vegetation is going to modify the intensity and you can say the distribution of precipitation. Try to understand that. Listen carefully and then understand what the use of vegetation in real sense, right? So if you have a vegetation, we commonly call it as a trees or certain any kind of shrub, herbs, anything that commonly is known as those vegetation has one important characteristic. What the characteristic it has? It is going to modify the intensity. Intensity meaning how strongly, amount, speed, right, of precipitation and distribution of precipitation when it has to fall. So this is the basic purpose of vegetation. Again I am repeating, vegetation has to modify the intensity and distribution of precipitation, right? So if vegetation will be there, then it has supposed to come in between the path of rainfall and the ground, because the rainfall has to, or any kind of precipitation has to fall on the ground. So that vegetation will become one kind of layer in between the movement of precipitation and the ground itself, right? And it become one kind of barrier. So that's why it is called interception. Have you got that? Is what is called interception. Or if in a technical term you need to understand. So as per the image you are able to see that we have a precipitation here, right? And this canopy people already know this. This is called crown, and but in terms of forest, right? When this all these crowns are coming together collectively, it is called canopy. So when precipitation will be there, so technically these canopy is going to capture the precipitation, right? First thing is that, and second, not only capturing but also return to the atmosphere either through the evaporation, or you have already studied this evapotranspiration method, that is interception. So you can easily in interception, I think you will already see this word interceptor when you have seen certain kind of police vehicle, right? So why this called interceptor, right? Because it has to come in a way, it has become a one kind of interference in the movement, right? When they have to catch any kind of thief or any kind of miscreants, they become a they're supposed to interfere in their path, right? They're supposed to cross their path to stop them. So that is interception. So in terms of vegetation has the same role here, isn't it? We have a precipitation, and this crown, or if it has a stand of canopy, you can say that. So canopy has to intercept the path of precipitation, right, before the precipitation has to reach on the ground, right? So you can easily look at here. If you again look at the image, This is the precipitation. So you just look at the amount of precipitation here, and now it has become a barrier for them. It's supposed to intercept the path, and now we just say the amount of precipitation on the ground itself, right? So that's why the statement that I have made you, there's a vegetation has to modify the intensity and the distribution of precipitation falling on the area or on the ground or anywhere. That is interception. I hope the term is clear to all of you now. Have you understood the term interception? Yes. So after getting that, there is one more thing that we need to understand: interception. That since I have told you that tree has to intercept the precipitation, but here the amount of precipitation that has been intercepted by the plant is varies with the species to species, right? Because because species has a different kind of leaf type, different kind of canopy structure, whatever is the humidity that is available there. So on that basis, the amount of precipitation intercepted by the plant varies as per the characteristics of the vegetation. Is it clear? So this is the meaning of interception, and through the image you can easily understand that. So if it has a broadly, but the size of leaf has a very important role for the interception. If the size of leaf is something like teak, a big size leaf, you are able to see that. So interception may be more, isn't it? And if it is a leaf size, so there is chance and interception may be less there. So that's the leaf type is one of the important thing on which the amount of precipitation intercepted has to depend upon. Then obviously canopy structure, this structure has also role in the interception process, right? Now the leaf drip, another thing that is the leaf drip that one need to understand, and you people already witnessed these things, right? Every time if you have rainfall, you just look at the tree, what kind of thing that you are doing, that there you can see that water is dripping off the leaf. You just look at the image, isn't it? Water first, when the rainfall is there, then water has to face this face of leaf, and then the water has to drip off from the leaf to the ground surface, isn't it? And this kind of activity you have already seen from your childhood. Even you are doing this kind of activity during your childhood with the plant itself. So that is called leaf drip. Now the same activity has a technical term that is called leaf drip. It means water dripping off the leaves here. Just together, there is the water droplets we have, and then it has to fall from this particular part. Sometimes as a human we are just shaking the leaf, or just using this hand, you are just doing any kind of disturbing activity to the leaf, and then water has to fall down. But if it is done naturally, right, leaf there is a water dripping from the leaf naturally, so that is called a leaf drip. Term is clear now? Right. Then we have another thing, that is the Stemflow and Throughfall. Right. So again, look at the image. This is the image of Stemfall. So you just do the arrow mark. Have seen this arrow mark here, here in the branches, and in the main stem, or it's called a bowl. That is stem flow. So if you have to say what is a stem flow, so basically, if you look at the image, what you have seen, that it is a it means is a redirection of water, right? You are just the tree has to redirect the water, right, through the branch and stem, right? Precipitation will be there, isn't it? When the precipitation will be done, so obviously, when if there is certain space between the leaf will be there, so precipitation has to enter in this particular path, and then it has to flow down. So when it get flow down by using the stem or branches, that is called stem flow. That is called stem flow. That is called stem. Is it clear? Have you got the stem flow? Or in simple, you can say that when this precipitation has to flow from branches and stem to come to the ground itself. Now, through fall. Just look at that through fall. Through fall. So as you have seen that, we all know that despite there is a arrangement of leaves on this ground structure, but still we will find certain gaps, isn't it? So when if rainfall will be there, so rainfall is not going any kind of resistance or any kind of, if there is any precipitation, so there is no any kind of resistance in between the precipitation, and it has to just fall to the ground directly. That's called through fall. Again, listen carefully. It means the precipitation has to fall through the gaps, right? If leaf structure is there, and if some you can see there's some space between the leaf, so this precipitation is unable to get any kind of resistance, and now it has to fall through the ground itself directly, right? So that is called through fall. I hope the term is clear again. So I have discussed you some the term interception, leaf drip, stem fall, and through fall. So now if you have any question of these four terms, first you have to ask. If you are unable to ask any term, good. Now the canopy drip, right? So again I'm representing the same tree, how the things is red arrows, stem flow is there. It means from the branch and the main stem, isn't it? And then you get yellow. I think you are able to see this yellow. That is through fall. Directly in between the gap, the precipitation will come down to the ground itself. Generally, the rainfall we are talking about. And then you have this canopy drip. What is canopy drip? So just look at the image. This purple arrow that has been representing. If there is a precipitation or the rainfall will be there, then along the canopy it has to flow to come to the ground. Just look at the image, isn't it? They're flowing along the canopy to touch the ground here. Right? So just look at this purple arrow, and you can easily understand what is this canopy drip. Right? It means you can easily see that this kind of a structure will get where either the precipitation means either the rainfall or snowfall has to move along the edge of the canopy, right? So that is called canopy drip. That is called canopy drip, and generally you will get this kind of canopy drip activity in coniferous vegetation where this snowfall is there. And in the previous class I have already explained you, isn't it? Because in the upper hill part we have this kind of structure of vegetation, or this crown is something of this structure. So if there is snowfall, the snowfall has to uh, move along the edge of the plant canopy to come to the ground itself. So when you talk about the canopy drip, so generally this canopy drip has to be happened in the coniferous vegetation. Is it clear to all of you now, all the terms? Fine. Now you have understood everything. Now the question is that why you need to understand this kind of these terms or these technicalities, what they use, and what they use for that in hydrology, or you can say that how this kind of activity that has been performed by the plant is beneficial. So as you need to understand a very simple way, if there is a precipitation will be there, and the height of cloud you have already studied in your agrometeorology. It may be 2000 meter, 3000 meter, something like that. So when something has to be fall from there, it will gain immense velocity, and when it's going to strike this ground surface with that velocity, it's going to rupture the surface, right? And there is one term that you already studied in social, splash erosion. So very splash erosion of that will result in the sheet erosion also there. If the rainfall or the snowfall has to directly hit the ground. So these characteristics of vegetation has a role to curtail down the velocity or the speed of the precipitation, and you have to make it slow down. So when velocity become less and less, because even the leaf, we have a layered leaf, you'll get that, right? So when the velocity will be less and less, so the less velocity it has to come to the ground. So that's why there is no erosion, or you can minimize the erosion through this activity, right? So these are the importance of all these characteristics of the vegetation here itself. So if you have any question up to this point, you can ask. I have explained you all these necessary terms related to vegetation, and also I have explained you the role. Okay, what is the role? Because the question will be there, like, what is the role? What the role of canopy tree? What the role of stem flow? What the role of all this leaf drip? Everything. So, so now if you have any question from any student, since 2 or 3 students are not responding, so there are lots of students also sitting over there. So now if you have any question, you people can ask here. So no question at all from N. Okay. Now the next important topic that has been given in the hydrology that we have to is infiltration, right? And as I understood that basics of infiltration you have already studied during your soil science, so we'll extend the knowledge from there itself, right? And you can easily understand the concept here itself. So first, infiltration, right? So the terms come from infiltrate. Infiltrate means you have to enter, right? If you have a boundary, then when you are supposed to cross the boundary, you just crossing the boundary, that is called infiltrate, right? So what is the meaning of infiltration in terms of uh, hydrology, right? So this is the simple meaning. Again, the process of entering rainwater in the soil strata of earth. The strata, it means soil horizon, the level of soil. So when the water has to enter, if it is called rainwater, basically when you enter into the soil strata of the earth, that is what infiltration. Even the names are saying in and fill, right? We have to in it, then you have to fill it. That's why infiltration. Have you understand that? The things has to understand like the infill. In, it has to enter, and then it has to fill the area. So when the rainwater, or if the water has to move to the soil strata, or you can say that the first layer of soil, that is called infiltration. Have you get that? Right, so this is one representation of this thing, infiltration. Have you gathered less infiltration? So non-porous soils and rocks. If the soil and rocks is not so much porous, if the solid will be there, obviously infiltration will be less. But if the soil is porous, it means if soil has a certain space in between, and rock means if rock has ruptured, or if rock has certain kind of cracks, then the infiltration will takes place, right? Then the percolation, right? Percolation. Obviously, this term also you have already studied. So, what is the difference between infiltration and percolation? You understand that? What is the difference? Percolation. See, the infiltration and percolation, there is the thing that one need to understand. When the water has to cross the first layer of this soil, that is infiltration, and after that, when the water has to move vertically under the influence of gravity, right, to reach the groundwater table, right, because after that we have a rock and we have a there is porous kind of soil structure is there. So if rocks will be there, if there is a gap between the arrangement of rocks will be there, or there is, as I told you, there is maybe cracks in the rocks will be there. So after that, water has to cross that part also there and have to reach the groundwater. So that is called percolation, infiltration, and after that percolation. The first infiltration will takes place, then percolation will takes place, right? Infiltration means the first layer has to be crossed, and then after that, if you're supposed to move vertically downward to reach the groundwater table, that is percolation, right? So this difference and this understanding should be known by you people also there. So if this both term is clear, infiltration and percolation, right? So now after that we need to understand this statement that when percolation stop, infiltration also stop. When infiltration stop, percolation is continue. What the meaning of this? That one should understand. When percolation stop, percolation stop means after that, it means after that layer there is no gap, there is no rupture, there is no any kind of cracks. So what will happen? Water has to deposit in that particular place, and the groundwater table has to be moved in upward direction, right? It means the area of that area will get saturated by continuous deposition of water there. So when it gets saturated, so there will be no infiltration will be there. It means water has to move on the surface. Water is not supposed to move inside the layer of soil, right? But when infiltration stop, percolation is continue. Obviously, infiltration means when the water has to cross the layer of soil, then percolation will be there. If percolation is not saturated, it means the lower area is not saturated, and if it has enough space to accommodate that amount of water, so percolation will be continued. So if percolation will be stopped, obviously there should be no infiltration, because it means we can say that soil, all the soil horizon gets saturated, so there should be no infiltration. But when infiltration is stopped, or no issue on that, infiltration, it means the first layer has to be crossed, the percolation should be continue there. So this statement will provide the relation between percolation and infiltration. Now we need to understand infiltration capacity, right? So what is infiltration capacity? So infiltration, as you know, the absorption of water will be there by the soil horizon. So infiltration capacity is basically, if you look at the definition, soil can absorb the water, and the rate for that, the maximum rate at which soil can absorb the water. You just look at the statement again. What is infiltration capacity? So it is defined as the maximum rate at which soil can absorb the water, right? It means how fastly water has to be absorbed. That is the rate. Rate. If the term rate is there, it means we have a relation with the time. Okay, what will be the time frame when the amount of water has to be absorbed by the uh, soil surface. So you can understand in this way, if there is a summer, in the summer season, if any rainfall will be there for 1 hour, 2 hour, so we have seen that within a few minutes, right, you are unable to get any deposition of water on the surface, because there is a dryness in the soil. So soil has to absorb the water with uh, full strength, you can say that, and within a minimum time frame. So that's why the rate is there, maximum rate. It means what is the time is required to absorb the certain amount of water by the soil. So if it is dry soil, obviously infiltration rate will be more, right? If dry soil means there is enough space to accommodate a certain amount of water there. If it's moist soil, it means already the soil has a certain amount of water. So whatever the space that is vectored there, that need to be filled by the infiltration process. So if it is moist soil, so obviously infiltration rate will be less, or if it is dry, so infiltration will be more. So as I told you, in terms of saturated and unsaturated. Saturated means it has certain amount of moisture is there. It means it required less amount of moisture. And if certain dry area is there, it means enough space is there, so it will need more amount of moisture. So if the dry soil will be there, so we'll get more infiltration rate, and if it is moist soil, so infiltration rate will be less here, isn't it? Okay, let me simplify you. Very simple. Forget about this hydrology for few seconds, right? See, I have to distribute 100 rupees among two person, isn't it? So one person is already 80 rupees and other person is 20 rupees. So which will get more, right? So obviously 20 will get more and 80 will get less. So similarly, the same thing is the dry cell and moist cell is the dry cell, right? It means this dry cell has enough capacity to accommodate more amount of water. So it will immediately absorb the water there, where it has already certain amount of good amount of moisture is there. So it will require less. So infiltration rate will be accordingly. So I hope you all get this term here. Is there any question to this point? Okay. Now the term field capacity is related to the hydrology. What the meaning of that? So if you have to simplify this term, so field capacity means maximum capacity of water absorption by the soil, right? Maximum capacity, or you can read the things there, volume of water that the ground can hold, right? This is the field capacity, maximum capacity of water absorption by soil. It means if you have a field or whatever certain um, quality of soil will be there. So what is the capacity, maximum capacity of that particular soil to absorb the amount of water there, that is field capacity. This term is clear again? So is there any question up to this point from anyone?